that they are within their distribution range. So we need to account for those connections. Another reason why we need to account for the species together, this is from a paper that was focusing on salmon. So this is kind of a salmon-centric view, but we can easily imagine how to adapt that for all the species, but they have interaction together. And if we think just about all the predation pressure that these species face, if we think about having multiple species at the time in the river coming back, then, you know, safety is a number. So that predation pressure, it's kind of diluted between the different species. They also, so this is the prey buffering. We also think about species like lamprey that can condition the habitat for Atlantic salmon. So there's a lot of different interaction within the diadromous fish community that if we do just a single species approach that we're missing, and we can benefit from those interactions to actually like get more money for our buck, like when we do restoration project and things like this. Other species interaction that we also need to keep in mind, because I'm focusing on the diadromous community, but we all know that these species, and here I'm using some river herring as example, they are food source for numerous bird, mammals. We all know the loop with the seal and the cod and the river herring. And if we don't account for that, then again, like we might be doing some work that we won't see the outcome that we expect because we're missing part of that picture. And of course, the human, because we are part of that ecosystem too, and we use those species. So this is really like the reason behind a little bit our project, is to kind of knowing that those species interaction, knowing that they face similar challenges, it's important to start putting those connections together, not only with the species, but also across the ecosystem that they use. So from the river, the estuary, the coastal shelf, and high sea, and really think about how the different species, the different diadromous species are connecting the different ecosystem together. And as a way to move forward, like ecosystem-based management. But you know, that's easy to say that, but when you think about more practical, especially in the Gulf of Maine, then we have 14 species, including tomcod and conger eel. So if you start thinking about 14 species, all their life cycle, life history, all those specificity that can get overwhelming quite quickly, as you can imagine. They also have different status. Some species still support commercial fisheries, others are threatened, endangered. So you know, this is kind of, that can get really messy. So what we're proposing to do here, to simplify a little bit that picture, is to use an ecosystem service approach. So ecosystem service are defined as the gain that humans get from using ecosystem. They are typically grouped in 3 categories: cultural, regulating and maintaining, and provisioning. And the ecosystem service is a tool that's been used for many years as a tool for sustainable resource use, because once you think about the different services that a species or a group of species is providing, you can start thinking about trade-off, about prioritization and all that stuff. It's also a way to provide a common language that is easy to understand for everyone. You don't need to know about the biology or all the specificity of a species to understand the importance, because then we use the service to highlight that importance. And it's also a way to focus on the ecosystem functioning rather than solely on the species. So kind of thinking about, what do we want the ecosystem to do? What type of role do we want the ecosystem to play for us, but also for the other species and you know, everybody in that ecosystem. So just to give you a little bit more detail on the ecosystem service in each category. So cultural service, it's really a way to account for social connection. We often, a lot of scientists, and I'm guilty of that, we often tell people, well, you should care because instead of listening of why people care about these species, this river, and the different ecosystems. So using the cultural services, it's really a way to extract that information and to understand better those social connection. And then we can use that to increase engagement and leverage support for the project, the different projects that are happening in our watershed and marine environment, etc. Regulating and maintaining, this is really about the ecological importance and the ecosystem connection, talking about marine-derived nutrient, prey-predation, so all those ecological functions that the diadermis fish are providing. And it's, like I mentioned just a little bit earlier, it's a way to refocusing the discussion on the ecosystem functioning rather than thinking of just just one species or a group of species. So that kind of eases a little bit the conversation between scientists and manager and the different player, like when we try to do, like, again, like thinking about larger scale project, but even the small scale project where we need to bring different people on board, we need a way to be able to efficiently communicate, and ecosystem service can provide that. Provisioning is the category that it's a little bit more straightforward. This is the direct benefit. So it's like food, like commercial and sustenance fisheries. This is the product that we use. We often don't realize how many fish-derived products we use on a daily basis. There's a lot of products that are fish-derived that we use in our household and all that stuff. And a lot of them are produced from diadermis species. So doing that assessment using ecosystem service, it's really a way that we can synthesize information about the ecological, but also the socioeconomic importance of these species and try to get into the more understanding of what we know and where we need to go. So that all come together into like kind of what we call a conceptual model, the diadermis watershed ocean continuum, so DWOC in short, where you have the ecosystem service and basically just the ecosystem that the fish use and kind of their movement to show that the ecosystem service are going to be delivered in a specific space in a specific time of the year. So fish move into freshwater ecosystems. Some will go at the headwater, others will stay in the mid portion, go to lake, coastal stream, while some species will connect estuaries, others will do coastal shelf migration, and other species will go at high sea. So this is really our conceptual figure is really just putting all those connections together, like things that we know, but we often overlook just because, you know, it can be a little bit overwhelming to think about that. But having in a picture and starting to think about those connections is really helpful for how we want to move things forward, like thinking about larger scale project and ecosystem-based management. The figure also highlight that, like when we think about management, fish are moving between different borders, even international waters. So it's also another layer to think about, because, you know, you can do a good job in your country with a species, but if the neighbor country where the fish is also going is not aligning their practice with ours, then this can be problematic. So it's just like really, like I say, like just putting those large scale picture together and connecting the dot and trying to see how they influence the work that we're doing. So then we can start thinking, you know, like I talk about the ecosystem service, that continuum, why it is important. So once we have all those points together into a conceptual model, we can start assessing and kind of thinking about how we're gonna dive into the more specific information. So one of the first steps, it's kind of to put all your species on that river, watershed, ocean continuum, and start thinking about the ecosystem service that they provide. So just an example here with river herring, we know that they provide recreational opportunity, spiritual, aesthetic, like aesthetic, just thinking about how many activity there is around the run. Like people get excited to go see the fish coming in the river, a lot of education opportunity. There's that social community around the fishing of the species, a lot of scientific data. Also regulating and maintaining, we know that they are involved in many predatory interaction. They serve as food, they eat some other, they provide a lot of marine derived nutrient. They also, when they are in sufficient number, they can be used as prey buffering for other species. So again, safety in number when they all come into the river together, provisioning food, bait, fertilizer. So this is just to give you an example of what we know on river herrings, for instance, and we can do that for all the species. But the important point here is that even if we know the importance of the service that these fish are providing, like we know they're providing the service, those services are not all quantified. So there's a need to go there a little bit. So using the ecosystem service approach was that was a way to kind of show that we need to deepen a little bit the knowledge that we have on the ecosystem service, and also even look at, are we missing something? Because this is what is known, but maybe if we start looking a little bit more in the ecosystem service, we'll figure out that they're providing more service than we thought. So by doing that, then we can get into integrated assessment and planning. So kind of doing your, management plan for your river, but keeping in mind that it's important to connect with the different ecosystem. So to do so, we can start with, whatever objective that we have. This is just a few examples that I'm giving you here. There's much more than that. But if we think about increasing headwater stream productivity, then the service that we're going to focus on is marine derived nutrient. That's the way to increase the headwater stream productivity. And the species that will move in those particular habitat is lamprey, eels, and salmon. And it's kind of interesting to think about that already, because for most of the river, for most of the watershed, eel and lamprey are not necessarily included into those plans. So that's just show there like the importance of thinking about multi-species, because by focusing on one species at a time, sometimes we forget other species that are also important for the objective that we're trying to achieve. Once we know all that, then we can get into that really what I call the integrated assessment, is then looking, okay, I want this fish here, want this species here to be able to increase that productivity. So what do we need to do? Where are the connectivity issue? Like what needs to be fixed? Like once we fix that, do we have enough habitat? Is it of quality and quantity, and so on and so on? And then you do that going down your watershed to the estuaries and the marine. And even if someone is not necessarily say, okay, I'm working in freshwater, just understanding also those connections with the other ecosystem and having that in mind can help twist the thing a little bit. So we account for those connections too, or find people that we can collaborate with to kind of do that whole loop slowly, step by step. We're not saying like, oh, this is how we have to do tomorrow morning, but it's kind of a step-by-step plan. Same thing for other objective. Like if we think of coastal stream resilience, this is we talk about that a lot, but we don't talk a lot about sea run brook trout or rainbow smell and the service that they provide that are key for those ecosystems. Maintaining sustainable stock, then that go back to what I was presenting a little bit with all those species interaction, because we know that those species are linked, and sometimes we need to restore more than one species at a time to be able to get there. So this is just as an example that can be done for multiple objectives and kind of get like that big picture understanding of what's going on in our ecosystem and how, and then getting into prioritization and all that stuff. So hopefully that makes sense. The other thing that we can do when we do that assessment is start thinking about what do we know, because this is also part of that assessment. It's also to define the research gap that are really important at the moment. So this is just screen capture, like a few stuff that we know, just to show there's a lot of good research that's being done. But so in our project, we did that for all the species and across the ecosystem, and we figured out that we know quite a bit. We know more than we thought initially, but there's a lot of stuff that we still don't know. It's mainly about, this is just an example of few species, but there's a lot of species that we don't know a lot about the ecosystem service they provide. We know quite a bit about salmon, a little bit about lamprey, river herring, but we still need a lot of quantification for different species. And the thing is that since they are at low abundance, it gets difficult to assess that. So we need to get on that sooner than later to be able to get that picture, that overall picture that we're trying to paint here. And then once we did all that assessment about what do we know, what we don't know, and all those bits and bolts, then we can really start addressing a list of the research gap that are really important, and not just research for research. I mean, don't get me wrong, I love doing research. I can, study those fish forever because they are fascinating. But we're kind of running against the clock here. So what DWOC can help do, it's really think about, okay, how those different research gaps can actually support management. And this is the one that we should prioritize at the moment, because like I said, we're running against the clock, so we need to get a little bit more into that. So just to give you a few examples, if we think of important research gap, that some of the important research gap that we defined through DWOC when we did our, like that whole exercise of getting into that knowledge and synthesizing all the information, a lot of stuff come down to how ecosystems are actually changing under climate change. Where are the migration barriers beside the obvious, like I mentioned, like dams are the obvious one, but thermal degradation is becoming more important as rivers are warming, ocean are also warming, estuaries are warming. So this is becoming really important, and we need to find a way to kind of understand that better, understand how the productivity of those ecosystems is changing. When we get into the marine environment, then we even have a little bit more of a black box when it comes down to, especially for certain species, about what are the habitat that they use. We don't necessarily know where they're going and what they're doing and how they interact. So this is kind of, you know, some of the deeper understanding that is needed right now. And then you think about climate change, and we know quite a bit of how like some aspect of the marine environment are changing. Same thing in river. We have quite a bit of understanding about how rivers are changing under climate change. Estuaries, we know a little bit less. And this is really important because this is by understanding all that we can get into understanding like what are the habitat that are the most compromised. So they need all these different habitat in freshwater and marine and estuaries to complete the life cycle. So we can start thinking about what are the most compromised habitat and what life stage are the most affected. And how this is linked to management. We talk a lot about improving species and ecosystem resilience. So those habitat are key into that. Like, do they have the habitat that they need to function and fully complete their life cycle? And where are the suitable habitat, the one that we need to protect or that we need to restore, including estuaries and management plan, all that stuff. So this is just to give you a few examples that, you know, by doing the exercise that I talk about, the integrated assessment and stuff, how we get into that it is useful to get into that knowledge side also, where we define research gap and we prioritize them, and we try to make sure that it is really in support of the management that we're trying to do. So what I presented so far in terms of how to use DWOC, like how to do like that assessment, getting into the research gap, was more into like even into a qualitative way. Like even if we don't get into numbers and all that stuff, like this is still useful to connect all those dots together. Hopefully I make that clear through the previous slide, but it's easy to think about how like the conceptual model, DWOC can also provide a foundation for a quantitative model, because once you're doing the assessment, it's easy to start creating layer or gather information about, you know, different aspect of the ecosystem. So if you think about it, you could have, you know, like there's a lot of habitat assessment map, you layer that with your species distribution, where are the connectivity issue, like all the different information that we can gather and put together. And then if you put that in some, for instance, a GIS layer, then you can easily superpose all the information and see where are your hotspot for action. So basically, where are the places in the different ecosystem that need the more attention, and start doing prioritization. But it can also serve as a layer of information to develop more quantitative model and get into that. So for instance, how many fish, if I do this, how many fish are going to be back, how many marine derived nutrient am I getting, and how this is increasing the productivity of my headwater ecosystem, for instance. So we do believe that DWOC provide like a solid foundation for all those quantitative models too. Okay, so how DWOC is really supporting ecosystem-based management, like those large-scale assessment or restoration project that I've been talking about. Like, we're not like expecting tomorrow morning, like everybody is going to say, hey, I'm working at the Gulf of Maine scale. We all understand that we have specific places where we work. I'm a freshwater ecologist. I know stuff about marine environment, but I wouldn't imagine like putting myself in a place where I'm actually like leading a project in the marine environment. But by doing that big picture assessment, then I know that I need to find colleagues, or I need to find people that can bring that knowledge so we can, you know, kind of close the loop and do the full life cycle across all the ecosystem. So DWOC is really just like kind of hopefully helping build those steps and see that big picture, and also understand that to really improve the service delivery across ecosystem and multiple species, we do need to scale up. So we need to find a way to kind of build across those scale, from the river to the watershed to the Gulf of Maine. This is also the way to improve the species productivity and the ecosystem resilience. I mean, don't get me wrong, the work that sometimes people, like, we have good example of river success story where the dam has been removed, a lot of work has been done, and there's tons of fish coming back, but this is one river, and I'm not saying this is not good, I'm just saying like we need more of that to kind of get into that species productivity and ecosystem resilience. Imagine that same success story across all the watershed in Maine. Like, it's like, wow, like we're getting there. Like, we know that we're going to be able to, you know, those species would be less vulnerable to climate change or other pressure. So DWOC is really just kind of highlighting these, but also showing that although we have all our little, you know, place where we work, and, you know, like we kind of limited to certain ecosystem or certain species, it's more a matter, it's not necessarily about the size of the project, it's more a matter of how it is planned and getting into that big picture understanding and making those connections and making sure we can connect with other people that can help us do that big picture. So some take-home message, we do think that DWOC is helpful to support, you know, some of the work that you guys are doing, some of the good restoration work, and trying to kind of put all those, you know, connection between the species and the ecosystem together. We already did a good work with developing the model, like through the literature, and kind of update all the information on the ecosystem service for the sea-run fish community. A lot of the literature is on Atlantic salmon, so there's a little bit of work to be done there, like I mentioned, to get the same level of knowledge for the other species. But we really show through our assessment that ecosystem service are key to the importance of this fish, and we can really use that to also ease the communication between the different actors in a project. And like I mentioned, like getting into like those research gaps and trying to align everything together. We are presently looking to develop more comprehensive quantitative models. So we're talking with other people to get into integrated modeling across all life cycle, but also across species. So to get kind of not just a population model for one species, but for multiple species at the time, and to be able to account for those interactions. So that's going to give a lot of information that DWOC highlighted, like that we highlighted through DWOC as research gap. And we do believe that using DWOC, even if, you know, like you say, okay, I'm going to do that full assessment, but I'm only working in this part of the ecosystem, just knowing all those connections is really important. And we do hope that this is a way to help, like, support the management of these species across the watershed ocean continuum, and be able to increase the productivity of these species across their distribution range. And also get into like talking to people a little bit more to understand about what are the challenges, because DWOC is also evolving. We have that figure, but the way we're going to apply it is also evolving. So it's really interesting to get feedback from presentation like this and hearing from people in the field, but also like ideas or your personal experience, and understanding what are the challenges when you try to scale up a little bit, when you try to get into those connections, and really like understanding the challenge to implementing ecosystem-based management. And here I just want to take a second to say like ecosystem-based management. It's often, when people hear that expression, they often are kind of, you know, it sounds big, it sounds overwhelming, but I would argue that more people do ecosystem-based management than they actually know that they're doing it, because we get often stuck into the definition of ecosystem, and this is kind of variable with the scale. So basically, ecosystem-based management, it's only just saying like we need to kind of think about those big picture thing and trying to connect those dots. So even people working at small scale can still be doing ecosystem-based management, and using DWOC, we do hope that, you know, we can help make those connections, and before you know, everybody's doing ecosystem-based management. And also hear a little bit more about, you know, what you see as research gap for management and more practicality like this, and then we can integrate that into DWOC and hopefully, you know, get into that loop of learning and modifying and getting the model kind of up to date to help people moving in the right direction. So thank you. And then I'm ready to take some questions.
All right, great. Well, thank you so much. Great, thank you so much, Valerie. That was really enlightening. And I think I'm actually going to ask you if you wouldn't mind going and putting that presentation back up and leave it on slide number 11.
Okay.
Your wonderful bigger picture model there. Okay, so for everybody who is with us today on the webinar, it looks like you can post questions both to the Q&A. And the other thing that I can see is I can see if you raise your hand so that you can be allowed to talk. So if you see on your dashboard, there's both a Q&A. We have one open question. I've answered one already, but I can also see you raise your hand. So if you want to make a comment, feel free to do so. Valerie, while we get to the questions, let me go ahead and just say a couple of comments. One, you know, I think when I hear the term EBFM or ecosystem-based fisheries management, I think you put the nail on the head. I kind of glaze over, right? Such a concept, so hard to grasp. Such a like, wow, what do I do with that? But when I look at this diagram that you've outlined here, I'm a very visual person. What I see here is, oh, gotcha. Now I'm starting to see the connections between fishes that leave from an estuary, they might go out to the open ocean, they return, and understanding how they cross these different water bodies and these different zones, where we tend to focus on one specific piece of this puzzle or mosaic as researchers. Seeing this concept laid out, I think, is just incredibly helpful. So as a layperson, really has helped me see what this entire EBFM thing is all about. And as you pointed out, there's something about, you know, when you're a chef, right, and you're cooking and you're missing that one ingredient, and frankly, it tastes horrible, right? It can taste horrible. But if you have that magic one ingredient or that pinch of salt, suddenly it can turn something relatively bland into something incredibly powerful and yummy. So I think that concept as well, looking for gaps and barriers to these species survival from an ecosystem perspective is incredibly vital. What's the missing pinch of salt? And really understanding where that barrier to the entire system may lie can unlock incredible potential that we may not see individually. So, okay, I'm seeing we've got a couple of questions here in the chat. So I'm going to go ahead and offer a couple of these here. Let's go ahead and field one for you. All right, so Val, is it fair to say that prior to the DWOC approach, management was focused on specific species or habitats, and or do you see a shift in that potentially as a result of your work?
Yes, I mean, there is definitely some example of multi-species management. Like we can think of some river in Maine where, although there was some work that was initially done with a thinking of salmon in the first place, that eventually we realized that shad or river herring are also like benefiting from the work that's being done and kind of getting like we can think of removing barrier as a good example. It's actually, so I think there's a shift that it's slowly happening even before DWOC, and we hope that DWOC can help like a little bit like pushing that and making sure that it keeps going in the right direction, because often you see not often, but you see a little bit of not push, I don't know how to say, like it's not a pushback, but people get, again, it gets complex. People think about it, like the first reaction is to think, oh, it's too complex, but it's not. Like, so we hope that DWOC can help like demystify a little bit of that.
Great. Well, thank you for that. Yeah, great. So here's another question for you. This one's coming in from Robin Alden. You mentioned that the scale of DWAC needs to be large scale. So are you considering habitats from the top of the watershed to international waters? But it appears the type of data you need for all these parts, whether it's cultural, maintaining and provisioning, really needs to be collected at a local scale. So how does it seems to be that DWAC is a framework for integrating what's at a local scale. Is that a correct assessment?
Yes, absolutely. So I did talk a lot about large scale because this is kind of the ultimate goal, but it's really building across a scale that I hope that DWAC is also helping. So putting that, because I mentioned it, we limited to the work that we can do. Like I say, I'm a freshwater ecologist, so that this is my realm, I don't, so putting like even those local knowledge, those little bits and pieces together through DWAC, like basically building a puzzle from that picture here that you're seeing and putting those little pieces together, it's what we're trying to show people too. So yeah, this is a correct perception.
That's great. Thank you so much. Okay, so I see a couple of questions that are similar, so I'm going to see if I can't combine these into one. We have a question from an anonymous attendee saying, we're running out against the clock. You said that. What's at stake for diadromous fishes? And where it seems to be perhaps salmon-centric at the moment, could you explain what the implications are for different species and what maybe you would focus on with a sense of urgency?
Yeah, this is a good question. It's also there's a lot of pieces there. We definitely need, I mean, climate change is it's the big thing that's affecting the fish, because if they were not as low abundance as they are right now, like we could expect, hopefully, that they would be more resilient to change because you have more fish. So if there's something happening, then they can resist better, But the fact that they are at low abundance, they are also more vulnerable, because if you lose, let's say you have 200 fish coming back to a river, you lose half of that, this is catastrophic. So climate change, like the way it affects all the ecosystem, that's really like what's the bigger threat to those fish. And it seems that we cannot do anything against that, but it's not completely true. There's little pieces that we can put together and make sure that we keep restoring our habitat and stuff. And the fact that we look at only at some species, or not only at some species, but the fact that we focus on specific species that are more maybe sexy, that the counterpart is that fish like lamprey that most people have what is that, like it's a bit of a ugly fish, they suffer bad rep also from the work that is being done in the Great Lake, where they are invasive, but just because of their aspect, like like they are not like in the mind of people as much. So it's easy to convince people to, hey, we need to do work on salmon. Would you be supportive of that project? When you talk about lamprey, for instance, it's a bit, but they are important for the ecosystem. So, and it's the same for other species that we hear a little bit less, like sometimes when we talk about rainbow smell, people, well, yeah, but this is just a small fish. But if they were in the same high number, they have impact on those ecosystems. So hopefully that answers the question.
Yeah, thank you. That was a great answer there. Thank you so much. I see here we have an attendee who has raised their hand. I'm going to go ahead and give Barbara Lawrence a chance to speak. Barbara, let's see how this goes. Go ahead, Barbara.
Yeah, I just had to unmute. Hi. Thank you for this. I apologize first that I had to miss some of it because we had a little deadline for an organization I run, which is called the Stewardship Education Alliance. And piggybacking on Robin's question, I've found that high school students, and in fact, students of all ages, are an underutilized resource in this kind of thing. And we give grants to teachers for projects, as well as to high school students for projects that will help us understand our watersheds better. And it seems to me that this would fit right in. We also require data collection now. And so I want to be sure that I can find where our students can send data that they find, and whether or not citizen science, which I realize as a social scientist, myself is not the same as the kind of research you're doing, but I think it can be useful, and wonder what you think.
Absolutely. I think there's more and more, I've seen over the year, more and more citizen science being used, and I do hope that's going to build into that. And what you mentioned with the program, with the school, that's really awesome too, because especially if you're collecting data, this is another good source of data. And we need to realize that, I mean, there's a lot of people that before I think we're kind of, maybe the data are not as good quality or whatever, but there's so many studies like on the social science side lately that have been showing that actually there's not that much difference. Sometimes you don't get the same level because, you know, like if you do a whole carrier on this, of course you're going to go in more detail, but and there's a lot of more organization that like are using those data. I'm thinking of Nature Conservancy, for instance, that has a lot of citizen science program right now, like asking people, hey, even if you just go on a walk on a river and you see, I don't know, like rainbow smell, like spawning ground, let us know, like, and then they can also, like, they do training and they give you sheet to kind of record the information to try to get those data a little bit more organized so they're easier to use for ourselves. So yeah, citizen science is actually like a really great thing, and there's more and more initiative, and I hope that we can build that a little bit better in our programs too.
Great. Thank you so much, Valerie. And I think I just want to compliment your response and speak to Barbara. You know, empowering the education of our stewards, you know, our young stewards is really incredibly important, and bringing forward, I would call it applied learning projects, really helps engage the community and the next generation in actual questions of interest. And I think it has a much higher response from the part of students and their sort of willingness and understanding of the system in which they then live and hopefully will thrive and continue to live. So our Eastern Maine Skippers program, which is another coordinated collaborative of educators, that's and Maine Center for Coastal Fisheries program. We do have an opportunity to, again, maybe bring some of this DWALK continuum forward to that group of educators to round out and expand the dissemination of this information. So Barbara, thank you so much for that question. You know, I think these collaboratives are so incredibly important. In the state of Maine, we don't have that many resources. Our holistic thinking is in some ways often limited by the resources afforded to us. But I think if we take the mosaic approach and think of a bigger map and where we individually fit into that, whether it's on the research side or on the education side, that complements one another, we can really achieve much greater goals and aims with that. So terrific. I'm going to go ahead, and I see a couple of more questions have been posted. Looks like we still have a couple more minutes. So from Jeff Reardon, I'm guessing this may be Kathleen. How do we get management and regulatory agencies to think and work at a DWALK scale? So it's salmon-centric now. Salmon are getting higher levels of regulatory scrutiny, more dedicated staff and funding, but other species, far more climate resilient and probably more important in terms of ecosystem services, tend to get ignored with all the focus on salmon. What would you recommend, Val? What, from your perspective, what do we need to do here?
Yeah, we definitely need to focus, to shift toward multi-species. And I would say, like, although some of the work is salmon-centric, a lot of species benefit from it. So I don't see it necessarily as a loss, even if, you know, if we remove a dam because of salmon, that opened the river for everybody, right? So dam is an easy example, but even some of the restoration, the habitat restoration, like we see other species that can facilitate their migration through those habitats because they are better quality, or even use them. So, but this is just to kind of say, like, not all is lost, because sometimes it's salmon centric, but we do need to do that shift. I think more and more agencies are open to do that. The next step for us is to really look into the management, because a lot of the conceptual model right now is based on more the science side and kind of how to put all those pictures together. But on the management side, there is constraint, and we need to look a little bit more at that and kind of come back with some of the proposed maybe solution, or to move things a little bit in a better direction there, and how to facilitate also aligning objective, because this is one of the big things. We all have different objectives for different reasons. So this is where it gets messy. So that's the next step for me, is to look into that a little bit better. So hopefully I'll come back with more answer on that side.
Great, thank you so much. We have a comment from a guest that the NOAA BWET grants are an excellent opportunity for us to expand on our educational offerings. Thank you so much for that. Yes, we are very aware of that and excited to pursue some of that to enable the kids in data collection. Stephanie has had several questions, and I'm going to give those to you here, Val. Stephanie, thank you for these. So, question about cultural context, as well as how citizens may contribute to this effort. But specifically, Stephanie is wondering, how much guidance do we have from our First Nations partners who maybe have lived in harmony with the ecological system for centuries? And how much, how was your model informed by that? Or how do you see it potentially being informed by that in the future?
We definitely need to, I mean, they're part of that picture, that's for sure. They're part of the, and then they're part of the people that I talked to while developing that model. They definitely, they're not the people that I had to convince about multi-species and connecting ecosystem. They're already on board with that idea, and see it as a struggle because it's hard. It can get overwhelming. So they were really happy to see the people that I talked with, the Penobscot Nation, for instance, they were happy to kind of see some of that moving. But we need to get into that place where we do a little bit more integration of traditional knowledge into our work like this, you know, and also getting into co-production of knowledge. So working a little bit more side by side, and it's definitely a big push in like whether it's research or management. There's a lot of push for that, and I think we see more and more in those examples. So hopefully, like, you know, the work moving forward, hopefully we'll be able to maintain that model and even develop better example too.
Great, thank you so much. And thank you, Stephanie, for those wonderful questions. So we have a question from Jim Chesney. Speaking of DWalk local, what is NOAA doing to measure the restoration of the Penobscot River and Bay after the dam removal? And Val, I'm not sure you know the answer to that, but if you do know anything, perhaps you could volunteer it.
Yeah, I'm not working directly on the Penobscot, but I know like there's been quite a bit of post dam removal monitoring. I think some of the funding is coming to an end, but I think there's definitely a will to keep doing some of the monitoring. But I'll have to ask my colleague to get more detailed answer. Sorry about that.
No, that's all right. I kind of figured that was the answer. But as we wrap up our questions here, I want to point out that there are significant projects underway to really put DWalk into action. We've never really looked at it necessarily with this wonderful diagram and framework in mind. But I think when you look at the work of partners of Maine Center for Coastal Fisheries, the Department of Marine Resources, and we do have a collective, the Down East Fisheries Partnership. A lot of us are specifically arranged and collaborating around this question, noting that, you know, these systems are interconnected, and by studying one system exclusive of the other, we may be missing significant connectivities, opportunities, and barriers. So you can continue to look forward to additional opportunities and updates from us on our work around this information. And again, I'm just seeing here actually that John Kosick has posted in the chat, in the Q&A, he's got some additional pre-dam removal data, and he's posted a link for us. John, I don't know if you want to be allowed to speak at all. Do you want to raise your hand? But I won't put you on the spot either. But monitoring is ongoing with our partners at Maine Sea Grant and DMR, and we'll certainly bring that information forward via our newsletters and other things through MCCF channels. Great. All right, I think it looks to me like we have just about answered most of the questions. Val, maybe give you a final comment if there's anything you wanted to say before we wrap up.
Just that, you know, like I think there's a lot of amazing work being done in Maine, and you gave some example like to some of the stuff that you guys are doing. And if people have any question or anything or ideas, like I said, the work is kind of evolving. We want to hear from you guys. We want to, you know, whatever we can do to help or answer questions, don't hesitate to reach out. We'll be happy to provide more information and help wherever we can.
Great. Well, thank you so much, everybody. I'm going to go ahead and close our session now. And thank you again for joining us today for lunch. We will be meeting again next month, March 17th. We don't yet have our topic. We have 2 potential topics. We'll go ahead and send out an alert once we have that finalized. And again, please join us monthly for these sessions. And in between these sessions, as you think of questions or ways you'd like to interact with us or ideas, don't hesitate to reach out to me, Val, or any of the MCCF staff on this topic or others. And again, thank you so much for all your hard work and everybody's interest in this incredibly invaluable ecosystem that we have here in Penobscot Bay in Eastern Maine. So have a wonderful Friday, and thank you again all. Take care.
Bye. Thank you.
Just stay on for a minute, Val. We'll make sure
Yeah,
we get the recording and everything. I think we can pause.